Why gravity or centrifugal force-based thermal-to-electric energy conversion is important. Author, Chen. Date, November 23, 2024. Before diving into the topic, let us first review the key points from the previous video. Previously, we discussed how Tolman's 1910 experimental results, combined with K.T. Chen's theoretical derivations, led to a thermal-to-electric mechanism that surpasses the limitations of the second law of thermodynamics. The principle is explained in detail in the previous video. Simply put, particles with the same charge, but different masses generate different potential differences under the interaction of the same gravity and thermal vibrations. These potential differences can trigger electron exchange, resulting in electrical energy output. This mechanism enables the conversion of thermal energy from particle vibrations into electrical energy under immense centrifugal force, even in the absence of temperature differences. Due to energy conservation, the rapid rotation of the generator would inevitably result in a temperature drop as electrical energy is output. It is speculated that, in the future, humans may have the technology to realize such an energy generation method. The significance lies in humanity's potential to use this technology to develop space vehicles capable of operating for thousands or tens of thousands of years without external energy supply. These vehicles could maintain life or system activity during long duration and long-distance travel in an environment with a background temperature of only 4K. Alternatively, AI created by humans might undertake such long-term, deep space journeys to explore the universe. There could be many methods to achieve this. Here is one example, and anyone can imagine other possibilities. Now, let's take a look at this proposed method. As shown in the illustration, the blue elliptical structure represents the spaceship's outer shell, and the brown ellipse represents its inner layer. The purple component is the centrifugal generator, and the line segments are electrical wires. Here, it is assumed that thermoelectric cooling modules are used between the inner and outer shells. Electricity generated by the generator maintains the inner layer at a relatively high temperature, and the outer layer at an extremely low temperature. The heat generated by the cooling process is retained internally, providing the thermal energy needed for the generator. The electrical energy converted from thermal energy powers the cooling module to maintain the temperature gradient. In this closed system, no thermal energy escapes, thus avoiding energy loss due to temperature decline. If the outer shell can be maintained at 4K or lower, it might even absorb energy from cosmic background radiation, raising the spaceship's internal temperature. Energy produced by the generator, aside from powering the thermoelectric cooling module, can be used by humans or AI. Waste heat generated during use is returned to the generator for energy production. This is just one idea. You can explore other possible structures and methods. Thus, one key importance of gravity, or centrifugal force-based thermal-to-electric conversion, is enabling long-term, long-distance space travel while sustaining active operations.